Now we look at how to set up a trigger on the oscilloscope. Without triggering, we cannot get a stable signal on the oscilloscope to make our measurements. The triggering system allows to capture our signal as a still picture on the screen. But the reality is, the wave is not a still like this. The voltage is constantly varying as it passes through the screen, like so. It's varying from high to low. But of course, that's if it's a nice slow wave like this. But the reality, it's never like that. For instance, we are looking at a wave of 3,000 hertz, which is 3 kilohertz, which means it's changing 3,000 times a second. So the reality of this is, if you take off the trigger, it actually looks like that. We put back the trigger, we can trigger it. To understand how triggering works, it helps if you know a little bit how the display system works on the oscilloscope. Think of it as a camera shutter, opening and closing to send a portion of the wave through to the screen. What the trigger system does is synchronize that shutter switching with the voltage coming in of the wave. For example, if the first block comes through here, and then the next block comes through here, if the trigger system arranges so each block overlaps the previous block, we'll get a still picture. But if the trigger system is random, where it just sends a block through at random, we'll get something like this, which is our typical untriggered wave. So what the trigger system does is look at that first portion of the wave on the screen and switch it through. So we get a wave coming up, another wave, and they all overlap, giving us our triggered signal. Now if we look at our trigger menu control system over here, the most important button we have here is the trigger level. And the trigger level does exactly that. It sets the voltage level where each block is going to be switched on here. For example, as I change the trigger level, we can see the start position changing. So for example, at this point here, it's triggered that will overlap the wave always at this point. If I trigger down here, it's always going to overlap there. So we're just setting the wave. It doesn't matter where we set it. Once we set it within the position shown by this arrow, if I set it where there's no voltage, for example out here, now it's looking for a voltage that does not exist, so it's not triggered. So setting our trigger level, the first thing you do is just adjust this to be the correct position. Now, as a matter of fact, it actually does not look at this first position. This arrow actually sets the position when it's at the midpoint of the screen, but it has the same effect. If we look down here, the arrow is saying we're set there and the midpoint is there. So we're down at this position, which is our trigger position here, 240 millivolts. So the other buttons on the trigger menu are as follows. So if I hit the trigger menu button, the next most important one is to select which channel it's triggering from. At the moment, it's triggering from channel 1. If I disconnect channel 2, so there's nothing going into it, and now select our source, it cannot trigger because there's nothing going into channel 2. So I'll switch it back to our channel 1. And the other final button you need to set is the auto mode button. This has a number of options: normal and auto. Normal is where the triggering will always look for some signal to trigger off. If no signal comes, it will not display anything at all. Auto will try to display something every time, so always set to auto. So just to summarize, for setting the trigger level, first thing, set the channel, check that it's auto, and then put your arrow in so we are setting the start position or the mid position somewhere the wave is, and they all overlap and we get a nice still picture. That is triggering.